Well, I told you we weren't going to learn any new rules in this unit, but we are going to learn how to apply them to different situations, and that's going to happen today. So the I can statement for 11.5 is I can multiply and divide exponential expressions with different bases. So write the word different right here. Everything that we've done so far relies on the fact that we've got the same base in each one of the exponential expressions. So as a quick reminder, when we multiply expressions with the same base, we add the exponents. And let me just highlight this right here. You do need to have these memorized. These are going to be a big deal on the test, so make sure you've got those memorized. When we divide expressions with the same base, we subtract the exponents. We talked about a couple different ways to do that. When we raise a power to another power, we multiply the exponents. And any number raised to the 0 power is 1, and a negative in the exponent means reciprocal. Okay, and that means, if we say reciprocal, that means from top to bottom or bottom to top, depending on where that negative exponent is. And we'll see them more often in the top, but they do occur in the bottom, and we'll talk about how to deal with that. Okay, and the next question is, do you have those rules memorized yet? Well, I am hoping that the answer is yes. If not, you need to make sure that you've got these memorized and have kind of a mental example of how you're going to deal with stuff like that. And then a couple quick things, just kind of a review of how we work with exponents and some of those typical things that we memorized in Unit 3 with perfect squares and perfect cubes. So 3 squared is 9. 5 squared is 25. Again, they should be on quick recall here. 3 to the third is 27. 9 squared is 81. 2 to the fifth. Now that was a little bit unusual, but 2 to the fifth, powers of 2 are pretty easy to memorize. So 2 squared is 4. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16, so 2 to the fifth, we're just doubling every single time, so that's 32 right here. May not have that memorized, but we did talk about powers of 2 in the last unit. Good thing to have memorized, because those are probably the ones that come up more than anything else. And 4 to the third, this is the one that appeared both in the perfect squares and the perfect cubes. This was 64. Now, most of the rules that we've learned so far depend on the bases of the exponential expressions being the same. It all depended on those bases being the same. So what do we do if they're not the same? What if we're multiplying two exponential expressions and they don't have the same base? Or we're dividing two exponential expressions and they don't have the same base? Well, if it's possible, we make them the same. We make them the same so we can apply the rules that we've learned. The rules only work if they have the same base here. So we make them the same so that we can apply those ideas. So let's take a look at how this works. I'm going to look at 5 squared times 25 cubed. So here's what we're talking about when we say make them the same. And just a word of caution here, these numbers sometimes get really big because the exponents get pretty outrageous. So if the answer or the coefficient to a particular problem is more than 1500, then we're just going to leave it in exponential form. So let's see what happens on this one right here. Now this is what we're talking about. Now I've got a 5 and we've got a 25. So we think about those. Can I write 5 and 25 with the same base? Well, if you take a look up here, 5 squared is 25. So this can be rewritten as, 5 squared raised to the third. So what I've done here is I've rewritten both of these so that they have the same base. This one was already a base of 5, this one was a base of 25, but instead of writing 25, I just wrote, hey, wherever there's a 25, I can write 5 squared. And now here's the cool part. We can apply the rules here. So we've got a power raised to a power, so this is going to be 5 squared times 5 to the, this would be 5 to the 6th, because we multiply those together. We're multiplying these together, so that means we add the exponents, so this is going to be 5 to the 8th. If you want to throw that in your calculator and see how big that is, I've got one right here. We'll pull that up. We're going to type in, and this is my older calculator here, so let's see what we get. We're going to have 5 raised to the 8th, to the 8th, hit enter. Yeah, gigantic number, so let's leave it like this. Okay, now on this particular one, I'm going to change colors, and I'm going to tell you this. Some of you might be pretty quick and catch this. You'll notice that this right here, if we said 5 squared is 25, well, what if I just replace that one? What if I said this is 25, and then we're going to multiply it by 25 to the third? Well, let's take a look here. This would be 25 to the first. This is 25 to the third, so this is 25 to the fourth, and we could say, hey, I've got this written as one simple exponential. we can stop right there and we can say, hey, we got the answer right here. This is 25 to the 4th. Now, it looks different than this over here, but let's check and see. I'm going to grab the calculator. Let's do 25 and let's raise that to the 4th power. If I raise that to the 4th power, I get exactly the same thing. Now, we're going to run into several problems like this. Now, some people are very quick and they can see both of those. If you can't, that's fine. Most people like this better, and that's why I did it that way. So we're going to have kind of a general rule. If there's more than one base you can use, we should use the smallest one. Okay? The smallest one. Now that is a general rule. It doesn't work all the time. There are times where it might be better to use the bigger one, but this is totally okay to do the problem this way. Both of these would be satisfactory for most people. That 5 to the 8th is going to be easier to work with because the base is smaller. So keep that in mind. So I'm going to come over here and we're going to take a look at this next one. This is 3 to the 5th and this is 9 to the 4th. What we want to focus on is we want to focus on the bases. A base of 3 and a base of 9. Those are both powers of 3. So we're going to write that as 3 to the 5th. 9 is 3 squared. So we're going to write 3 squared raised to the 4th. So the only thing that changes here, and I'm going to highlight this, is that 9 changed to a 3 squared. It still represents the same value. 3 squared is still 9, but now we can use our rules because these have the same bases. So this is 3 to the 5th on the top. This would be 3 to the 8th on the bottom. So when we simplify this, I've got 5 3's on the top, 8 3's on the bottom, so that means 5 of them are going to cancel. That means there's 5 left. Always a 1 left, and this would be 3 to the 3rd. Now, that's a pretty decent answer right there. That looks great, but because 3 to the 3rd is a small number and we know what it is, let's go ahead and write this as 1 over 27, and I'm going to circle that. Okay? All right, let's go ahead and do this problem right here. We've got 2 to the 10th over 4 to the 5th. Again, we focus on the 2 and we focus on the 4. Can we write those with the same base? Same base, and I'm going to write need same base. Well, let's see. 4 is 2 squared. So here's what we're going to do. We're going to leave the 2 to the 10th on the top, and we're going to write 2 squared, and we're going to raise it to the 5th on the bottom. So where there was a 4, I'll put that in parentheses, I can write a 2 squared there. So this is going to be 2 squared to the 5th. So take a look at this. 2 to the 10th on the top. 2 to the 2 times 5 is 10. 2 to the 10th on top, 2 to the 10th on the bottom. Those are going to completely cancel, so the answer on this one, oddly enough, is a 1. We can use a 1 right there. So again, taking a look at this problem right here, we want to make sure that they have the same base. So I've got an 81 and we've got a 9. Now the reason we did these warm-up problems right here is to kind of remind you of some of those perfect squares and perfect cubes and perfect powers that we're familiar with. So this is what I'm going to do with this one. I'm going to make this crystal clear if I can. So this is going to be 81 to the 4th, and then times, we'll do 9 to the 5th. Now what we need is we need these to be the same base. Same base. So keeping in mind that 81 is 9 squared, here's what I'm going to do. I'm going to do 9 squared to the 4th times 9 to the 5th. Now I know this other part over here where we do the 9 to the 5th, that kind of looks crazy to write it this way. But let's go ahead and do this because it kind of stays uniform with the other one. 9 squared to the 4th, power to a power, we multiply those, so that's going to be an 8. 9 technically to the 1st to the 5th, so that would be 9 to the 5th. So you can kind of see that we've kind of mimicked the action on both sides. We've made these look just the same, and now we've got one where we're multiplying them and the bases are the same, so we just add the exponents. So this is 9 to the 13th. Certainly not going to throw that into a calculator and see what we get there. So just keep that in mind. It is possible to do this a couple of other ways. If this is what you see first, go right ahead. It would be possible to change both of those into a base of 3, but by far it's easier on this one to keep it as a 9. All right, if you want to do it as a 3, go right ahead. Kind of a challenging problem there. So let's take a look at the next one. We've got 25 to the 6th and 125 to the 5th. Now I'm hoping that you recognize that we actually have to change both of these. We can write both of those as a power 5. So remember, 5 to the 1st is 5, 5 to the 2nd is 25, and 5 to the 3rd is 125. So here's what we're going to do. Where there's a 25, we're going to write 5 squared to the 6th. Where there's a 125, we're going to write 5 to the 3rd to the 5th. So what we did here is we basically said, look, I've got to change those so that I can use my rules. I've got to make those the same. So 25 is 5 squared, 125 is 5 to the 3rd. Now we can go ahead and apply our other rules, power to a power. This is going to be 5 to the 12th on the top. This is going to be 5 to the 3 times 5 is 15. And then we can start simplifying. There are 12 on the top, 15 on the bottom. 12 of them cancel. That's going to leave 3 down here. So that's 1 over 5 to the 3rd. So I could circle that, but this is a pretty small number. So let's go ahead and change that. That's 1 over 125. Circle that, and then we're done. Okay, taking a look at the next one here. We've got a 16 and we've got an 8. Now a lot of people think, hey, we could make them both a 4. You cannot write those both as a 4. Up here, we ran through the powers of 2. And if for the heck of it above that I wrote the powers of 4, so 4 to the 1st is 4, 4 to the 2nd is 16, 4 to the 3rd is 64. Okay, you can see that I can't make an 8 out of those. So I'm going to be stuck using a base of 2 here. So here's what we're going to do. I'm going to put parentheses around this and this. This is 2 to the 4th. So 2 to the 4th raised to the 3rd. Okay, 16 equals 2 to the 4th. And 8 is 2 to the 3rd. So this is 2 to the 3rd raised to the 6th. So we get 2 to the 12th times 2 to the 12th. Ooh, 2 to the 18th. 2 to the 18th, yep. And now we've got the same base. We're multiplying, so we add the exponents. So this would be 2 to the 30th. So I'm going to go ahead and circle that, and we are all set to go. Certainly wouldn't want to plug that in the calculator. That's going to be a big mess. Okay, we're going to take a look at this right here, and this is crazy. We've got 2 exponentials on the top and 1 exponential on the bottom, but I'm hoping that you recognize this. 3, 9, and 27. All of those are powers of 3. So this, if I wrote it, 3 to the 1st to the 7th, 3 to the 2nd to the 3rd, and 3 to the 3rd raised to the 5th. So 3 to the 1st is 3, 3 to the 2nd is 9, 3 to the 3rd is 27. Again, that's why those powers are so important to have those memorized. So this is going to be 3 to the 7th times 3 to the, 2 times 3 is 6, 3 times 5 is 15. Let's take a look here. Let's see, same base, we get to add the exponents, so that's going to be a 13 here. 7 plus 6 is 13, and 3 to the 15th. Now, after all of that mess, take a look at what happens. There are 13 on the top and 15 on the bottom, so 13 of them cancel, leaving only 2 on the bottom, so that's a 3 squared on the bottom. I suppose we could leave it like that, but much better if we wrote it like this. That is just 1/9 for the answer there. Okay, last one. We're going to take a look at this, and I'm going to blow this up over here. So here's what we've got. We've got 4, we've got 16, and we've got 64. Now, we could write all of those as powers of 2, but unlike this rule right here, I said generally, that's a common rule, we could write them all with 2, but stop and think about this. We wrote up above that 4 to the 1st is 4, 4 to the 2nd is 16, and 4 to the 3rd is 64. So in this case, it's going to be way better to use the 4 because one of them already is written with a base of 4. So I'm going to replace this with a 4 to the 3rd. So it's 4 to the 3rd for 64, and there's the square. Times, this is going to be 16, so this is going to be 4 squared raised to the 4th, and then times 4 to the 6th. Now if we wanted to, I suppose for uniformity, we could do this. We could put the 6 outside and the 1 in there. So again, just emphasizing that every one of those can be written as a power of 4. So this is going to be 4 to the 6th, 4 to the 8th, and 4 to the 6th. So when we put all of those together, we end up with, let's see, this would be 14, and another 6 would be 20. So this is 4 to the 20th. Definitely too big to write down. Let's not even bother typing that into our calculator, and let's take a look at the last couple of problems here. Great skills that we're working on here. This being able to change bases and then apply rules is kind of a deeper thinking skill, so really good to practice this and make sure you put effort into this. I do have a couple of thought questions here. It says, how would you simplify the following? 1000 to the 3rd over 100 to the 5th, and 49 to the 10th over 7 to the 5th. So same trick here. We're going to simplify these by writing them with the same base. If I have a 1 followed by 3 zeros, that is a 10 to the 3rd. So 10 to the third is 1,000. And 10 squared is 100. So here's what we're going to do. We're going to write both of those with a base of 10. So this is going to be 10 to the third, and this is going to be 10 squared to the fifth. So this is 10 to the ninth on the top, and this is 10 to the, let's see, that would be 10 to the 10th on the bottom. So after all of that, look what we end up with. We end up with a 1 on the top, and we end up with a 10 on the bottom, because 9 of these canceled with 9 of those. Okay, so I'll go ahead and circle that. This one, I'm hoping if you take a look at that for just a quick second, you know what to do with that, because it's the same as what we would do up above. 49 is 7 squared. So this is 7 squared raised to the 10th. I'm thinking ahead there. Over 7 to the 5th. So this is 7 to the 20th over 7 to the 5th. So that would be 7 to the 15th. And 243 is a power of 3. Which power is it? Now, you may recognize this. If you don't, you can grab the calculator and you can do this. So let's just try this out. I'm going to slide this over, and we're going to do, clear this off, we're going to do, we already know that 3 squared is 9, and we know that 3 to the third power is 27. So let's do 3 to the fourth power, 81, and let's do 3 to the fifth power, fifth power, 243. So it is the fifth power. Now, I suppose you could figure that out if you didn't have a calculator. You could just do, 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, 3 to the fourth is just times by 3, and you get 81, and then 3 to the fifth would be times by 3, and then you would get 243. You could do it by hand, but if this were much bigger of a number, it'd be pretty tough to do. So good skills right here. Keep these in mind for the future. Make sure you practice this. We're going to be doing this for a couple of days. Good luck with the assignment.